So on objective one, I did an extra video where I went over the process of evaluating expressions, which is very important in order to check your work when you're trying to do two-step equations and inequalities to make sure you're getting it right. I would never actually submit a question or the test if I haven't checked it to make sure it's right. And I showed you how to do that when I did the equations and when you did it in inequalities. But there's one more trick that you can use during the test, especially on questions that have multiple choice, that can help you do a good job in the test, which is actually use the actual multiple choice in your favor. Now, I actually talked a little bit about this when I did the solving equations part, but I'm going to do a video just about that because it's a great skill. You technically don't even need to solve these equations when you have the multiple choice. All you have to do is evaluate them. So, for example, I go question by question here, trying to figure out if this could be an answer. So, for example, 4 plus 6 times negative 2, and I'm using the answer here from the problem. I'm even going to do a different color so you can see what I'm talking about. So I'm putting the answer, or A, in the problem, and then seeing if I get that 4. So I'm looking for 4. If I get 4 from this, then I know that it's the right answer, right? So let's see. So if I'm doing this one, 6 times negative 2 is going to be negative 12. So this is 4 plus negative 12. And that is negative 8. So this is not 4. So that is not an answer. I can rule that one out. All right, let's try this again with the 12, right? So same thing, 4 plus 6, plug in the 12, right? 6 times the 12. Now, 6 times 12 is actually 72, all right? So if you do 4 plus 72, that is 76. So once again, not my answer, because that doesn't make sense. I'm looking for 4. Next, let me try it with 0. 4 plus 6 times 0. Now, 6 times 0 is just 0, so that means that's just 4. And that is what I'm looking for. I got my answer. This is it. I'm still going to check the last one just to be sure that I did this right. 4 times plus 6 times 20. And 6 times 20 is 120 plus 4. That would be 4 plus 120, which is 124. Now, these other answers may look absurd when you actually check them, but trust me, they're there because they're usually common error answers of people that made mistakes, common mistakes in the solving process. They didn't pick them by accident, right? Now, I did pick a slightly easier one to solve from the ones in the test, but I wanted to show you an example of that, right? So you don't even need to solve it. Now, you could have solved this, right? The first step here would have been subtract 4 from both sides. If you do that, you would get 0 on this side, and this will cancel out. So then you would have 6k equals 0. And then if you divide both sides by 6, you would just get k equals 0. Actually, for me, it's much easier to solve it than to do all this work. But technically, you don't need to solve it. You can just plug it in, is what I'm trying to show you. So you can use one or both of the strategies to try to make sure you get it right when you're in the test, right? By the way, if I had gotten it right, this 0, I would have still gone to a similar step to this to double check that I was right, regardless, because they are going to use distraction questions a lot. So how does this apply to when we're doing inequalities? So I'm going to actually just solve this one first. All right, so I would do that by subtracting 9 from both sides, since it's being added first. When I do that, this cancels out, and I have negative 3x is bigger than or equal to negative 9. I have to divide both sides by negative 3 next to get rid of that negative 3. It cancels out, and then my final answer would be x. Because I divided by a negative, I have to actually invert the sign. And I did that, and then negative 9 divided by negative 3 is just 3. So very clearly, C is our right answer, right? And by the way, you can check that makes sense. Let's see how I could check that. I could use, say, any number smaller than 3 should give me an answer. So let's say if I plug in 0 to the original problem, right? So let's try that. This is a check step that I'm doing right now. 3 times 0 plus 9 is going to be bigger than or equal to 0. Yes, this is just 9, which is bigger than or equal to 0. So that worked. I always try to check twice with inequalities. So let me pick a different number. Let me pick 3 because equal should be included. So negative 3 should be plus 9, should be bigger than or equal to 0. Let's see. This is negative 9 plus 9, which is 0. And therefore, 0 is bigger than or equal to 0. So that works. So I used two numbers which are smaller than the x, and both of them proved that this solution does make sense. So I'm very happy that C is the right answer. But I could have done this in a different way, right? I could have actually gone backwards and look at each of the options and see if they made sense. Like, say, for example, this is saying that any number that is bigger than or equal to 3 would work. So let's say if I picked 4 and I try that, same process that I just did. So I'm going to pick any number bigger than or equal to 3, so I'm going to use 4. And let's see if that works. When I do that, over here, this becomes negative 12, right, plus 9, which of course is negative 3. But negative 3 is not bigger than or equal to 0. This is not a true statement. This is false. So that answer would not work because I already found one value, 4, that made this false. All right? Let's try a different one. Now, this is where it gets tricky with inequalities, okay? Because and this is why you have to check more than one value. In here, it's saying any number that is bigger than negative 3 could work. Now, we've already tried 0, and we've already tried 3, and then those did work, right? So if you picked those values, you may have think that B was the right answer, right? Because 0 and 3 are indeed bigger than negative 3, and they do work. They do satisfy the statement. But what about 4? 4 is another one that we just tried, and it doesn't work. It makes the statement false. And 4 is bigger than or equal to negative 3. So you can find a single value that makes the statement false. That must make the question false. But that shows you why it's important to try a few values when you're checking inequalities, because it is not as straightforward, because some values might work, but not all values will satisfy that, as you can see here. And then here, once again, values which are smaller than negative 3. All right, now there are values which are smaller than negative 3 that will work, because as you can see from the problem, all values which are smaller than negative 3 are also going to be smaller than 3. That's pretty obvious, right? So if you look at the number line, and if you look at 3, and then looking at all the values below that are included in our solution set. I probably should have done this earlier on to help you visualize, right? So all of these are included on the right answer, which is C. So if you look at negative 3, and you look at the values below that, those were also going to be included on my answer, right? So D could perhaps work. However, the problem with that is that this ignores this entire section here of values that also do work. What about 0? What about negative 1? All of those values should work. So this is a complete solution, and that's why that's wrong, right? Now that we have the graph, I actually want to look at the other ones to see why they don't make sense. Look, values bigger than negative 3, right? Now, they will work over here, but by the time you get here, these would not work, right? So these should not be included. These values here don't work. And values bigger than negative 3 should include that section. So that's why B doesn't work. And of course, values bigger than 3 definitely don't work because they're already in that section as well. So when you look at this graphically, right, it kind of makes sense why the other options don't make sense. So I'm just showing you that you can rationalize a problem, especially if you use graphs like I just did, to kind of understand why or why it would not work, and that you can plug in some values to check to see. It is true that it's not as useful with inequalities as it is with equations to actually plug in from the question, but it's not entirely useless. It's something you can do to double check that you're doing it right. So I wanted to take the time to show you that this is an extra strategy you can do in the exam to make sure your problems are making sense.